This video is about parent function. Y equals x is a linear function. Let's make a table. -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. 0, 0, 1, 1, 2, 2. -1, -1, -2, -2.
Use a straight line to connect all these 5 points.
F of x equals x. Domain is all real numbers. Range is all real numbers. Odd or even function. For even function, the graph is symmetric about y-axis. Odd function, the graph is symmetric about the origin, 0, 0. Y equals x is symmetric about the origin, so it's an odd function. For one-to-one function, vertical line test and a horizontal line test. Vertical line test is to check whether the graph is a function. For this graph, we will draw any vertical line. We found out there are 2 intersections, so this is not a function. Second graph, let's draw any vertical line. We only have one intersection for each vertical line. This is a function. Horizontal line test is to check whether the function is a one-to-one function. We know this is a function. Is it a one-to-one function? Let's draw any horizontal line. For each horizontal line, we only have one intersection.
So,
this is a one-to-one function. For this graph, let's draw any horizontal line. We got 2 intersections, so this is not one-to-one function. Why one-to-one function is so important? Because only one-to-one function has an inverse function. For any horizontal line, only one intersection, then this function is a one-to-one function. And behavior, x approaches negative infinity. F of x approaches negative infinity. X approaches positive infinity. The function is approaching positive infinity. How to decide the increasing intervals? From left to the right, check the graph which goes up. Do not confused by this arrow. As long as from left to the right, the graph is going up, then this part of the graph is increasing. So we have 2 increasing intervals. Arrow means the graph goes forever from negative infinity to A, union from 0 to C. When the graph goes down from left to the right, then this graph is decreasing. We have 2 parts of the graph decreasing. from A to 0. Union from C to positive infinity. The graph of y equals x is always increasing. So the increasing interval is all real numbers. No decreasing interval.
Y equals absolute value of x.
Absolute value function. Let's make a table. 0, -1, -2, 1, 2. 2, 1, 0, 1, 2. 0, 0, 1, 1, 2, 2. -1, 1, -2, 2.
Then connect the points.
Domain is all real numbers. Range, no ending point at the top. We do have a bottom point, 0. So range is from 0 to positive infinity.
Since the graph is symmetric about y-axis, this is an even function.
When we draw this horizontal line, we got two intersections. So it's not a one-to-one function. When x approaches negative infinity, f of x approaches positive infinity. When x approaches positive infinity, f of x approaches positive infinity. Increasing interval from left to the right. The graph is going up from 0 to positive infinity. Decreasing interval, check the graph from left to right. The graph is going down. So the decreasing interval is from negative infinity to 0. Y equals x squared. This is a quadratic function. 0, 0, -1, 1, -2, 4, 1, 1, 2, 4, 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. Then we smoothly connect these 5 points. F of x equals x squared. Domain is all real numbers because no ending points on the left side, no ending point on the right side. Range, no ending point at the top. We do have a bottom point, 0. So range is y greater than or equal to 0. Since the graph is symmetric about y-axis, it's an even function. When we draw this horizontal line, we got two intersections. So it's not a one-to-one function. When x approaches negative infinity, the function approaches positive infinity. When x approaches positive infinity, function approaches positive infinity. From left to right.
This part of a graph goes up.
So increasing interval is from 0 to positive infinity.
From left to right, this part of a graph goes down. So decreasing interval is
from negative infinity to 0.